Need to integrate external services or microservices into your FastMCP application while preserving their full client lifecycle. You'll see how to mount servers in proxy mode, which maintains complete isolation between components while still allowing seamless access through your main application. We'll compare direct mounting with proxy mounting and show when each approach makes the most sense for your architecture.
Direct mounting, default when no custom lifespan. Main MCP, mount API server prefix equals API. Proxy mounting, preserves full client lifecycle. Main MCP, mount API server prefix equals API as proxy equals true. Mounting without a prefix, components accessible without prefixing. Main MCP, mount API server.
This demonstrates the server composition pattern, where independent FastMCP servers are combined into a unified system while maintaining modular boundaries. The pattern enables hierarchical organization by treating servers as first-class components that can be nested, linked, or isolated, similar to how microservices are orchestrated in distributed systems. What makes this distinctive is its dual approach: static composition for performance-critical scenarios and dynamic linking for runtime flexibility. The pattern works through two complementary mechanisms: importing for one-time component copying and mounting for live delegation. Importing creates a snapshot of components at composition time, ideal for finalized modules where isolation and performance matter. Mounting establishes a bidirectional link, where the parent server dynamically routes requests to child servers, enabling real-time updates and shared state. Both approaches use prefixing as a namespacing strategy, preventing collisions while preserving the logical structure of each module. This approach solves the scalability challenge in growing applications, where monolithic servers become unwieldy. By composing specialized servers, e.g., auth, database, AI services, teams can develop components independently while the framework handles integration. The trade-off is performance. Mounted servers introduce delegation overhead, making imports better for static configurations, while mounts excel in dynamic environments where components evolve at runtime. The pattern is particularly valuable in AI agent systems, where tools and resources must be organized hierarchically but remain discoverable as a single endpoint. Let's break it down line by line.
Direct mounting, default when no custom lifespan. Main MCP, mount API server prefix equals API.
This performs direct mounting of the API server under the /API prefix. The default mounting strategy shares the main application's lifespan, meaning the mounted server starts and stops with the parent application. Use this when you want simple, unified lifecycle management without proxy overhead.
Proxy mounting, preserves full client lifecycle. Main MCP, mount API server prefix equals API as proxy equals true.
This enables proxy mounting, which preserves the full client lifecycle for the mounted component. Unlike direct mounting, it maintains separate request handling and state management for the /API prefix, preventing conflicts with the parent server's lifecycle. Use this when the mounted component needs independent request processing.
Mounting without a prefix, components accessible without prefixing. Main MCP, mount API server.
This mounts the API server without any URL prefix, making all its endpoints directly accessible at the root path. Use this when you want seamless integration, where the mounted server's roots appear as native roots, eliminating the need for path prefixes in client requests. FastMCP server mounting. The mount operation lets you compose servers into hierarchical structures, with 3 key variations shown in the code: direct mounting for performance, proxy mounting for full lifecycle preservation, and prefix-less mounting for seamless integration. Prefixes create namespaced isolation, while prefix-less mounting enables transparent fallback chains where multiple servers can respond to the same unqualified names. The automatic proxy detection, when custom lifespans exist, prevents silent behavioral differences between development and production.
The server that disappears into another becomes more present than the one that stands alone.